All right, hello everyone. We're just going to do one quick practice problem solving linear, nonlinear systems together, and then you'll have one to practice on your own. So remember, first things first, we want to take our two equations because they are both y equals. That's great. We don't have to do any algebra to switch it up. We can just go ahead and set both of these equations equal to each other. So we have negative 3x squared plus x plus 2 is equal to x plus 4. Now remember, our goal is to get this equation equal to 0 so that then we can go ahead and use the quadratic formula and solve for our x-intercepts if there are any. Okay, so I'm going to go ahead and do this. I'm going to subtract x, because this x right here is positive, so the opposite is negative, and then subtract 4. Okay, again, we're going to just go ahead and keep this equation balanced. And that leaves us with negative 3x squared. X take away, x is just 0. So we really don't need to write it, but we can if we want to, just to help us when we're going through the formula. And then 2 take away 4 is negative 2. Okay, so that means that my a value is negative 3, my b value is 0, and my c value is negative 2. When I go ahead and I plug those values back into my equation, I get negative b plus or minus the square root of b squared minus 4ac all over 2a, and then I'm just going to go ahead and plug in the values that I know. So I have negative 0 plus or minus the square root of 0 squared minus 4 times negative 3 times negative 2 all over 2 times negative 3. Okay, and then from here, we're just going to go ahead and solve using algebra. So starting off with what we have inside our radical, we have 0 squared just being 0. And then we have negative 4 times negative 3 times negative 2. So that's going to give us in total negative 24 all over 2 times negative 3, which is negative 6. Okay. Notice that when we go ahead and we solve on the inside, we do get negative 24. Okay. So when we're talking about, are we going to see these two equations intersect at any point? Because the number inside our radicand, is a negative, that means, remember, that we're going to have complex solutions. In the case of whether these two equations are ever going to intercept, that would mean that this parabola here is not going to touch this line here. So we're going to go ahead and say for this one, no real solution. Okay, or no solution is fine in this case. But again, when we get a negative inside of our radical, we have to end up saying no real solution in terms of, will this parabola ever intersect with this line? No, that's not going to happen. We're going to get one of those graphs where we end up seeing it as, say that this is the parabola here. This is not an exact sketch at all of what this turns out to be. But say that we have this line here going like this, and then we have this parabola like somewhere, let's say here, and we know it's opening down because the a value is negative. We have something like this happening. So again, the parabola will never touch the line. So that's how we end up getting no real solution. Okay, so now you're going to take that same process, but let's say that this number wasn't negative. You would actually go ahead and solve for your two solutions. And remember, whatever your x value comes out to be, go ahead and plug it back into this equation or this equation. Linear one would probably be easier, and solve for your y. So you could tell me what the coordinates for the point or points are. Because remember, it is possible to have one or two or no solutions like we saw in this problem, when solving these nonlinear systems.